Hello, and welcome to a British Cartographic Society Teatime Talk. My name is Chris Tributus. I'm the coordinator for the Teatime Talks and today's chair. Today's speaker is Duncan Cameron, and his talk will be the Cameron Aquatic Projection, a new view of the world ocean. So for what should be an interesting talk, I will hand you over to Duncan, where he will tell us more.
Right, well, let me introduce myself. I'm Duncan Cameron, we recently completed the work on creating a new projection, which is designed to illustrate the world's oceans as they really are. Now, this is an idea which I had in the back of my mind for quite a long time. It occurred to me, that the world's oceans, the world ocean, is a single unbroken space, if you like, if you want to call it that. And yet, no map projection I ever saw actually showed the world ocean as an unbroken space. It was always chopped up in various ways. And that's, it seemed to me that it was possible to make it into a single space. Other picture? Yeah. This is just an example of the sort of image which you will see, because over the last couple of years, I've been doing quite a bit of research on oceans and the parts that oceans are playing in climate change, global warming, CO2 emissions. And one constantly comes across maps that look like this. This is actually to do with temperature, in fact. Temperatures cold in the Arctic and the Antarctic regions, hot in the tropical regions. And one constantly comes across images like this to illustrate concepts relating to the ocean, which is fine, except, of course, that it doesn't show the ocean as a continuous space. The next one. Next image. Yeah, that's another one. This is an image relating actually to climate change. And it's showing the change in ocean acidity as a result of CO2 emissions. And it's a good enough map in its own way, but it fails really, doesn't it, to give a proper image of what we've got in front of us. We here in Britain are a little bit prejudiced because, you'll find that Britain is sort of stuck there in the top right corner of the image, and you can't really see what's going on around it very well. So I would like to see an image which actually shows all of this ocean space as a single integrated space. If you go on to the next picture. Now, I'm just going to, at this stage, tell you a little bit about some of the attempts to create an ocean aquatic projection in the past. This is an image by John Bartholomew, and he actually created this in 1940, which wasn't very long, actually, after the Antarctic continent was properly mapped. And it's a very interesting image of the world ocean. And it shows the globe from the point of view of an ocean. However, of course, there are limitations to it. The three different lobes, if you like, are the same width, and that means that the Pacific Ocean is actually cut into three parts. The Indian Ocean is a single unit, and of course the Arctic Ocean is split between three different pointed areas at the top and the bottom. So it's a very attractive image, but it's not really very suited to illustrating, let's say, dynamic processes taking part in which are happening in the world ocean. And that's the next one. Next image. Yeah, this is another sort of image which you find of oceans and oceanic projection. And in this case, of course, you've got very large scale cuts between the different oceans. So you'll sort of see different parts of the ocean projected, and the land is used as a in between the ocean images. It's an attractive image in its own way, but it doesn't actually show the world ocean as it really is. Do you want to go to the next one? Next one, yeah. This is by Spielhaus, the cartographer, who was quite well known, I think. He produced a lot of images of oceans and finding ways of interrupting the global image. And this is very effective in a way, of course, because it shows the Arctic Ocean, the Atlantic Ocean, Indian and Pacific Oceans as a single unit, which is more or less what we're looking for. But of course, there are major illogicalities about it, really, aren't there? Europe and Africa are presented to us almost as they are, with very little distortion, whereas, of course, South America is completely disemboweled and has a completely different sort of shape. And also in the top right of the map, you can see the rivers in Northeast Asia are hugely exaggerated in scale. So it's a good map. I have seen it used actually for data, actual research data, and it's quite effective, but it still is not a very true image because it has huge inconsistencies. Next picture. So what we're doing here is I'm starting to look at what we've actually got in front of us on the global layout of land and water. And the first point is, of course, that all of the oceans, the Atlantic, the Pacific, the Indian, Arctic and Antarctic, are actually part of a single space. There's no natural boundary between any of these oceans, actually. Now, this is a view of the southern part of what I'll call the world ocean. And what it shows you, of course, is that the continents, really by chance, I would say, each of the major continents, Asia, Africa, the Americas, actually terminates at a single point in the Southern Ocean, pointing towards the Southern Ocean. So there you've got it. You've got at the top, you've got Tanjung Piai, which is the southernmost part of Malaysia. You've got Cape Froward, Cape Agulhas in South Africa, and Cape Froward, or rather Cape Brunswick in the southern part of South America. Next picture. And in fact, it's rather remarkable, and I find it really rather satisfying, that each of these capes, each of these southernmost points on the major continents is actually recognized as such. So this is in South Africa, and the sign says this is Cape Agulhas, and this is where the Indian Ocean and the Atlantic Ocean meets. The next one. This is this Tanjung Piai, as it's called, which is the southernmost point in Malaysia. And it's looking across at Singapore, which of course is an island. So that's the southernmost point of Asia. The next picture. This is quite a wild image, isn't it? It's it's the southernmost part of Cape Brunswick, which is the southernmost point of South America. Of course, Tierra del Fuego is actually an island. So this is actually the southernmost part of the South American mainland. And it's looking across at Tierra del Fuego, a very wild image. But again, it's recognized as such. Next picture. So what we've actually created. Now, at this point, I was actually working with Jennifer Johnson, who was a very gifted cartographer, and she was able to put together images which corresponded. to these the structure. So here we've got the three southernmost points, and then in the middle of it, we've got a point. This is actually the center of the world ocean. And what I'm calling here is the center of the projection. It is rather satisfying to see that it's sort of somewhere between Antarctica and Australia, so two island continents. And this is the center of the map. This is where the map projection actually starts from. The next map. Now, what you're having after this is each of these points is the starting point for what I call a lobe. So north of there, this is the Arctic Atlantic lobe. The southernmost point are Cape Brunswick, Cape Agulhas. And so this is what the Atlantic Ocean and the Pacific Ocean and the Arctic Ocean look like. So that's the Atlantic lobe. Next one. This is the Pacific lobe, starting on the right from the southernmost point of South America, and on the left is Malaysia. You get a rather different shape here. You get a sort of triangular shape. And of course, in the far north of there, you're looking at the northernmost point of the Pacific Ocean, where you've got a short strait, of course, going into the Arctic Ocean. And that's the Bering Strait. In fact, what you've got is that the world ocean actually links up with itself via the Bering Strait. Next one. And this, of course, is the Indian lobe. From South Africa to Malaysia. Next one. So what we got now at this point, we were quite stuck because we were able to produce rough approximations to the sort of map we wanted, but we had to find a really good mathematical cartographer who could actually do the mathematics of making this a reality. And this actually proved to be remarkably difficult. So we were able to produce very good images for somebody to work from, but again and again, I was able to contact cartographers who said it was a good idea, they were interested in it, but they couldn't work out how to do the maths. And Christopher Kirkovits, who's Hungarian, he teaches in a university in Hungary, and he was actually able to do the maths. So we're very lucky to have this. He's a brilliant mathematician, and he's done what I consider to be a brilliant job in making this real. So this is actually the end result of his work. You can see here the world ocean as a single shape. And you can look at that. You can see the center of the projection in the Southern Ocean. You can see the Atlantic lobe going off to the left. And it's rather narrow and sort of surrounded by complicated shapes of land-related shapes. Whereas on the other side, the right-hand side, you've got a great big round Pacific Ocean joining up with a large space of the Indian Ocean. And that is a new shape. I don't think you have seen that shape anywhere else. I'm rather proud of this shape, actually. What you can get here is a picture of the world ocean. But in fact, of course, the world ocean actually is physically linked to the hydrosphere, which is essentially water on the surface of the earth, i.e. rivers and lakes. So actually each ocean is surrounded by watersheds. And this projection actually integrates the two. So these white shapes here are actually the watersheds which surround the ocean. So let's just go on. Yeah, next one. This is a map of the world's ocean, the world's river basins, if you like. And what you see, of course, is a very complex mix of different sized river basins. But if you look at South America, and you can see the Amazon basin, it's the biggest one of all, isn't it? The Amazon basin in South America, a huge great basin. It extends all the way across South America, right up in the far west, South America, to the peaks of the Andes, very close to the Pacific Ocean. And then south of there is the River Plata River in yellow. And again, it's a very large basin. It extends a lot of the way across South America, but it runs into the Atlantic Ocean. Same in the north part of the Northern America. You've got in purple, in pale violet, you've got the Mississippi. So what you're seeing here is an Atlantic Ocean surrounded by a lot of very large watersheds. And when you look on the other side, for example, on the west coast of South America, you'll see actually that the river basins are very tiny, short rivers. They're actually very fast rivers with lots of water in them sometimes, but they're short. So what you get, if you go forward now, please. Yeah, this is a picture of the watershed of the Americas, the western coast of the Americas. So what you're getting is a very, very long, narrow shape. From the south, starts off southern Chile, goes all the way up South America, around Peru, through Central America. And then when you're getting to North America, it starts to widen a bit. But it's a very distinctive shape, isn't it? Very, very long, very narrow. Next one. And this is the opposite, if you like. It's the Atlantic watersheds along the eastern part of the Atlantic Ocean. And you're getting their huge, great watersheds. But of course, they go narrow in places, don't they? If you look at the Eastern Mediterranean, you're looking there at Palestine. And in fact, the watershed with the Indian Ocean is very, very close to the Mediterranean. And similarly on the eastern part of the Black Sea. So a very different sort of shape. If you go back to the South American watershed, it's interesting because at this stage, as a result of the way we operated, you're getting a type of shape on the map, which you don't see in conventional world maps. Can you go on again to the next one? Yep, okay. And the next one. So this is another version of the map showing the world ocean surrounded by its watersheds. And another one. Yeah. Now this one includes actually the rivers, at least a good selection of rivers. So look again at South America. You've got a huge, great, complex network of big rivers. Whereas if you go further to the right of the map, you've got a very, very narrow watershed all the way around the first part of the Pacific Ocean. And again, the Arctic Ocean, which is very small, of course, is surrounded by a very dense network of rivers. Whereas, of course, in other parts, such as North Africa and the Arabian Peninsula, Iran, there are a few rivers. So this actually, I believe this actually does actually demonstrate important aspects of how the world's hydrosphere actually operates. And it shows a single unified unit. So when we're looking at this, we can think about things like anthropogenic pollution, industrial pollution, plastic pollution coming out of rivers. So you can see these rivers here. You can imagine different types of pollution coming out of them, but also different types of nutrients coming out into the ocean, and the relationship between a river basin and the surrounding parts of the ocean, which I think is a very interesting map. Just by the way, if you look at the top area of the map, north of India, you'll see there the Caspian Sea. Can you see that? Of course, the Caspian Sea and the Aral Sea near to it are actually seas which drain internally. So I've tacked it on the top of there, but actually it's a separate system of rivers and two seas. I rather like this image when you look at that, because it does actually show a relationship between parts of the globe, which you don't see in a conventional map. If you think about, if you look at the Antarctic continent there, and then you move downwards through the Atlantic basin, you realize actually that the Arctic Ocean is more or less the same size as the Antarctic continent. But of course, one's water and one is land. It's a nice symmetry, which you will never see, I don't think, in a conventional map. You'll also see that the Indian Ocean and the Pacific Ocean together create a great big sort of blue circular blob with a certain number of islands in it. In some cases surrounded by very narrow areas of land. Whereas of course the Atlantic Ocean is a very complex mixture of seas, internal seas like the Mediterranean and the Caribbean, with very great big river valleys, Congo, Amazon, Siberian rivers. So I think this does actually demonstrate aspects of the way the world's oceans and the hydrosphere look, which you're not seeing in other maps. Next one. So I'd like to just finish this by talking about uses of it. I think thermohaline circulation, are you familiar with that? It's to do with a very slow moving movement of water through the entire globe. It actually starts off sort of south of Iceland, where melting ice in summer moves down into cold water, moving down through the northwest Atlantic, and then it gradually moves all the way down the Atlantic, picks up heat, and then it starts to actually circulate around the Antarctic continent, and then it sort of bits of it move up into the Indian Ocean and the Pacific Ocean. And it's a very important, ecologically, a very important distributor of heat around the globe, and it moves very, very slowly. It says in the bottom right, you see that? About 1 kiloyear to make a loop. It takes about 1,000 years for all that water to move around it. Apparently, with climate change that's taking place, there is a possibility that this entire circulation might break down. It's a very good subject for a map, in fact. And next map, this is a rough sort of approximation to how the thermohaline circulation would look in reality. When you're seeing there, you've got loops and loops and loops of water moving round and round and round. The Arctic, moving down from the Arctic, moving around the Antarctic, and then mixing water through the oceans. There's a great deal more we could do with this, but this is just a starting point. And one more picture. Yeah, I'm just suggesting here ways of using this projection. This is a good map of the impact of climate change upon biodiversity in the oceans. And it shows that the impact actually in the Arctic and subantarctic is really, really powerful. Whereas in the center part of the hottest part of the globe, it's not so much so. This map would look absolutely great if it was done in my projection, in my opinion. And that's really where I am on that. I should have mentioned, by the way, that as far as images is concerned, Jennifer Johnson did really important work in making it real and making it possible. But also Chris Kirkovich, as a brilliant mathematician, he was able to find a way of pulling all these different lobes together. And what he actually had was that he has 4 different projections, essentially. He's got a projection in the center for the central area, and each of the lobes has a slightly different projection. And then he introduced a zone of transition between the central area and the lobe, in which case one was transformed into another. I'm not much of a mathematician, and so I don't actually understand all of his maths, to tell you the truth. But it was his very original and highly professional maths which actually made this happen. So that is Christopher Kirkovich. So that's it, really. Have you got, was there anything any of you would like to ask?
Okay. Right. Thank you very much for that. That's been a very interesting talk and providing a very different view of the world ocean. So now we'll pass this over to the Q&A.
I hope you've got questions.
I'm sure people have quite a few questions. It was a very interesting. It has been a very interesting talk covering quite a lot of interest. And here, yes, we've got we've got the first one in. So
yeah,
how long did the project take?
Well, I wasn't sitting at my desk, for months on end doing it. It was patchy. How long did it take? It took ages. It took absolutely ages, actually. Jennifer Johnson and me, we worked together. Honestly, I believe she's in the audience somewhere. Can you remember, Jennifer, how long did we work together on this for? I mean, it was several months, actually, when we put together a kind of proposal with no maths in it. And then we spent a long time contacting various people around the globe who were cartographers. We got 2 responses, actually. Quite a lot of people said they didn't think it was very interesting and they didn't really want to be involved. But other people said it was interesting, but they had no idea how to do the maths. And Chris Kirkovich actually had the maths to do it, and I'm very grateful that he spent the time on it, in fact. Having done that, then he actually did the maths, and then we put it together into an article. Have you seen my article, by the way? Have you seen it? It should have been published by now. I don't actually know if it has been published or not. Anyway, we wrote the article for publication. It was accepted. Then we wrote the article for publication, and then it came back after we submitted it with huge numbers of questions and doubts and problems. So I think actually we rewrote the article, I think 3 or even 4 times in places before it passed through the judges. So it's been a very long and painful process, actually, to be quite honest.
Okay,
we are there now. Yeah.
Yes.
Yeah,
no. It's good. It's good to see that you're able to persevere and get through, and at least there's an interesting piece of work that's come out of it. So
yes.
Okay. The next question we have is speaking as a fairly amateur cartographer, are there ways I can use this to explore visualizations?
What do you mean by visualizations? Can you explain what you mean by that?
Oh.
Um, if you mean making something visible, yes, I think that's the case. I think actually what's really, for me at this stage, what's really interesting about this projection is it can be used to demonstrate a whole lot of really very significant issues. Let's talk about, the impact of climate change, CO2 levels, etc., pollution upon the aquatic environment. There are huge, great impacts of different types. Everything from, sea level rising to species changes, and virtually everything about that, you could make a map to demonstrate that. So it would actually be a very good tool for visualization. And I would actually be quite interested in getting involved with that. Visualizing a range of environmental issues, where the ocean is the key element in that. I think it's a very good tool, and that's what I would like to use it for.
I'm sure we can.
I have to say, sometimes cartographers seem to make maps up just for the sort of intellectual interest of doing it, but I do see this as being a useful tool.
No, I'm sure. Yes. Oh, no. I've got an clarification on this. I would love to try and use a projection for some of the uses you've mentioned. Is there a way in GIS I can get hold of the projection?
GIS is
yes. I think well,
if you want to get, if you're interested in this, can I suggest you contact me and we could talk? Would that be acceptable?
Yeah, I'm sure we could pass on anyone that wants to talk to you over this, and
so I'd be very happy to do that. Actually, I'd be very happy to do that. Yeah. I'm actually at the point where I really do want to produce things which look, to be involved with producing stuff like this.
Okay, we'll happily make sure that people have contact with you to see how they can make good use of this.
Another question there.
Another question. Well, we've got quite a few. So it's did you consider, or was it ever a concern, that the direction of north now seems to be lost?
Well, it's very interesting actually, because to me, one of the things I enjoy about looking at the map is that it actually turns a lot of things on their head. And of course, anyone who thinks about world maps has got this concept of north and south, up and down, top and bottom. And in fact, that kind of makes sense, doesn't it? In a way, but I feel in this case, north and south doesn't make that much difference, strangely enough, because it's all part of a single whole, if you like. I'm not sure what the idea was behind the question.
Yes, I think with the fact that traditionally it's hard to see where the north is, but
yes.
I think the interesting fact of this is that since the north since south happens to be the dead center of this
yes,
this map.
But it's a remarkable fact. It's a very remarkable fact that the center of the projection isn't that far from the South Pole. It's curious. I mean, when you think about it historically, really, world geography is a result of trade and communications between European via the sea, and they're sort of somehow within a grid of conventional north and south. But it's curious when you look at the sort of illustrations in articles about oceanography, they're very often those sort of Mercator type projections. The North Pole disappears into a huge great space with no relationship at all. I'm not sure how to answer the question.
No.
Is it a problem? Do you feel it? Okay. Yeah.
No, it's not. No. It sounds like you have given a.
I've given it some thought.
Yeah.
But if anybody wants to communicate to me about that, I'd be very interested to talk about it.
That's no problem. As I said, we'll pass on any interest.
Yes.
So, another question here: have you considered also including underwater relief, an idea of the depth and explaining the movement of heat, cold could be interesting.
Definitely. Underwater relief. There's a potential there for an extraordinarily beautiful map. Actually, if you put them together, the hydrosphere, the river systems with the sea, then you would have a very nice, highly detailed map of underwater topography. And then it'd be surrounded. Imagine you'd have a sort of very, very, very dark blue for the deepest oceanic trenches, going up towards sort of very, very light color along the continental shelf. And then going up from there, you'd be going into river systems, and then you'd color code the rivers from something very similar to continental shelf color to something much, much darker, maybe, when you're looking at the sort of, the headwaters of the Ganges system, or the Amazon system. It could actually produce an amazingly attractive map. It really would be something quite remarkable. So I'm quite interested in that one, actually.
Okay, right. So on to the next question. So yes, so when introducing endorheic basins such as the Okavango in South Africa, how did you choose the oceanographic basin, Atlantic or Indian, to position it closest to, as it doesn't flow into either? The same question for the Caspian and Aral basins.
Well, it's a good question, that one. In terms of the sort of rough maps we produce up to now, the small scale basins in South America, for example, or in the American West, you can more or less overlook them, really, because they're not big enough to make a difference. But certainly the endorheic basins in Central Asia are actually significant, and it's not easy to think about intellectually watertight argument for how you deal with them. You could I've got to admit there that what you have to do, I think, is to tack them on to some other watershed. But I can't think of a very good intellectual argument for that one. Do any of you want to suggest something there?
I'm sure people will be happy to offer up any thoughts, and again,
share any thoughts with me, please.
Yes. We'll make sure that happens. We'll make sure that happens.
Yeah. I do feel a little bit uneasy about the Central Asian basins, quite honestly, because they're neither one thing nor the other, actually, are they?
Yes. Okay. So we've now another interesting question. This is beautiful. I'm an artist making porcelain maps and 3D pieces representing the globe as different projections. Recently exhibiting at Arts Council England lottery-funded project, which explores how maps influence our sense of place and belonging and identity. And they'd like to make a piece based on your projection. And so if you if you want to make contact, just send an email to our to the BCS admin, and we will make sure that request is forwarded on.
I'd love to see that. It's a great idea, actually. It's a really great idea. So what you say about sense of place is very important. Now, as we're coming to understand so much more about climate and oceans, it's becoming more and more significant for the sense of place,
Mhm.
what's going on at the ocean. It's
Yes.
a very good idea. Let me know, please.
Yeah.
Yes.
Okay. And it's a thank you very much for the insightful presentation. Again, we all agree with that one, I think. And the North Q. This is a question here again. The North Q. This was the North Q question is followed by, how do you reference a location? Is there a grid? So is there a grid for?
Well, yes, there is a grid. I mean, if you look back at the world map with the hydrosphere attached, that does have a graticule. It's the same graticule as it's a standard world graticule. So it is there. Yes, it is. And in fact, the thing is, I didn't actually mention this, but Chris Kirkovitz was brilliant at finding ways of minimizing distortion. So the angular distortion and the areal distortion is actually very low. Considering it's a world map, it's got a very low levels of distortion. His system of finding 4 different projections for each zone, and then using areas of transformation to bring them together, it actually has created a world map with a very low areal distortion. If you study his maths carefully, you'll see how he does it. It's bits of it are beyond me, quite honestly, but it's a great achievement, actually.
Okay, no. So yes, that's good. And now jumping on to the next one, it's more following up on our previous one. It's the just highlight the fact that underwater relief lacks real modern data. Only 20% has been surveyed, so it's hard to visualize any real detail. Just the data doesn't exist. So it's but I'm sure
it's patchy. In some areas, it's very well mapped. In other parts, it's not. Actually, the Spielhaus map, which I showed you, remember the Spielhaus one? I saw that in an article not long ago, which was about mapping of the ocean floor. And what they'd got was the Spielhaus projection, and then they'd actually somehow or other put together a database of all the mapping operations which have been going on, and then they'd drawn lines across the map to show where these expeditions had been. And it was an amazing image, actually, of how much or how little in some parts of the ocean has been mapped. You're quite right. Yes.
Okay.
I don't know. We've just got to use the data we've got.
Absolutely no problem.
But obviously, when you get into this area, you're probably having to deal with a vast amount of data to make it worthwhile, of course.
Okay.
Yeah.
Okay. No, well, thank you very much. That's been a very interesting talk, and I think we're going to have to wrap it up for now.
Is that it? Okay.
Yes. If there's any questions that haven't been answered, we'll pass them on to you, and then you can
please,
and we can try answer them as.
Yeah. Well, I would be very happy, tomorrow morning to see my computer overwhelmed with questions from you. So please get in touch and ask me questions. I'm very keen on that.
Absolutely no problem. So anyway, to everyone, I want to say thank you very much for joining us today. I want to thank Duncan once again for his talk. Has been very interesting. We've had a lot of good questions, and it's very interesting to see that's something very different in the way of for a projection. Thank you very much for joining us today. I want to thank Duncan once again for his talk. Next month's talk will be from Josie Wilson with the talk, The Child's Understanding of Their School Journey. We look forward to seeing you in the future. But for now, thank you and goodbye.